Welcome to QLab. Today I'll be showing you how to separate colours in inks using paper chromatography. In this video it'll be a guide of how to use paper chromatography using marker pens. If you'd like a detailed explanation of how chromatography works on the molecular scale, why not check out the video where we separate colours in natural products. So the first thing you need when you want to run a chromatogram is a nice rectangular piece of paper with a ruler line drawn on the base, and your solvent, when you come to place in the solvent, should not go above this line, as in the level of the liquid. As it starts to rise up through the paper, it will. Each of these spots that I've put there is for me to place my samples, and I'm just going to use some pens today. So there's a little bit of black ink, there's a little bit of red ink, a little bit of purple, and finally a little bit of green. And I'll write those there just so I don't forget. B for black, R for red, B for purple, and G for green. So that's prepared our chromatography piece of paper. So what we're going to do now is place this in the solvent system. I'll show you how to do that. So I've got the small cup with a little bit of the solvent system, it's isopropanol, set up. And we're going to take a little piece of paper with our colours on and carefully put it in. I want to do it so you can see it easily. And then we're just going to give it a little hat. And that's to keep the solvent system in, because otherwise it might just evaporate. I'm going to try and zoom in so you can see really clearly what's going on. Right, well, this has been taking a good long time, so what I'm going to do is take it out now and we can see what we have to do with it then. So let me zoom out. We can take cap off, lift the piece of paper out, lay it down. First thing we want to do is quite quickly just get a ruler and draw a neat line there where the solvent has come up to. Then we want this to dry out, so we just shake it thoroughly. So as we can see on here, when we look at the black, there's a little bit of pink here, and what I'm going to put up for you to see is a photograph taken with better contrast so that you can see these colours better, because the camera isn't picking them up terribly well. So with black we can see it separating clearly into like a little blue and a small bit of this reddish pink colour. In the red, all we can see is this reddish pink colour. In the purple, we can see the reddish pink colour, but not much else. And then for the green, we can just see a little bit of blue. So we can work out that each of these colours are comprised of different mixtures of the same things. Now, what I'd like to do is just compare this chromatogram with one run in water. So let's have a look at one run in water. And so now we'll just run this chromatogram using some water. Now you can see I've had to sellotape this chromatogram in because I found when I add the water the paper gets a bit more flimsy and so it starts to slip down the glass. So I've just secured that at the top. Now I'm going to add the water and then we'll see what happens. There we go. That's enough water. And then we'll just put the cap on, like so, and I'll zoom in so we can watch this as it starts to go up the paper. So it's been quite a while now. In fact, it's been about an hour that I've left this one running for. What we're going to do is we're going to take it out of the glass and just let it dry. But I've got to take the little piece of sellotape I put on. Let's take that off first. There we go. Take it out of the water. Just shake off any drips. Let that dry for a little while. So here are the two chromatograms. One that we use the propanol or isopropanol, and the other we used water. And we can see with the isopropanol we had these very nice little dots. They didn't separate very much, did you? See a bit of the pinkish colour here, a bit of the pinkish colour there, and this slight little blue, a slight little bit of blue here, so we can start to think that black has probably got this blue colour and this pink colour in it, the green has this blue colour in it. Then we come over to the water. I know this took a very long time to run, but it's actually separated really nicely. So we can see in the black there's definitely this blue colour. There's also sort of a pinkish colour and a little bit of yellow colour as well at the back. So there's possibly 3 colours, maybe more in there. If we left it to run even longer, it would have separated even more. We can see distinctly 3 colours in there. Then we come to red, and there's this sort of orangey colour here, and then a pink here. So it might be that the red is actually made from more than one colour. I thought that was just going to be one, but it may have more than one colour in it. And then the pink, we've got this sort of magenta, the purple I should say, we've got this magenta and then this blue colour as well. So that purple is made up of those 2 colours. And then with green, we've got this lovely blue again. This blue seems to be a very common one, isn't it? I think it might be cyan blue. And then there's a yellow that's been mixed with it to give the green ink. So in this water chromatogram, it was really easy to tell the different colours in those inks. And that's what makes this technique so useful. It can help us separate complex mixtures into individual things to look at. Just before we finish, I want to address one thing, which is I cut slanted sides in this sheet here so that the water was only along this part here, and it led to a more even flow of water up the page. Sometimes when you pop things into the solvent or the liquid, you can get a little bit that shoots up the side and it doesn't go evenly up the page. And I was noticing that was a big problem with water, so I decided to cut those sides. I hope this was useful as a guide to paper chromatography. If you like this video and you'd like to see any of our other projects, check out the videos on our channel. Thank you.